The diagram shows a square, a diagonal, and a line joining a vertex to the midpoint of a side. What is the ratio of the area P to area Q? So area P is this, and area Q is this. So we can start with because we've not been given any lengths of sides, so we can assume that the square is of side 2x. So we assume the square has side length equals 2x. So therefore you see the other problem, yes, okay, we got the 2x side length, but then we have these triangles that we need to find the area of. So suppose I have to name them, so I can call them, say, A, triangle A, and I can call them, the area is A and the area is B. So, and then let me name them A, B, and C, D, E, and F. So we don't need the A and B. I think it will be too many unknowns if we have the A and B, because to find the area, before we find the area, we need to do something about these two triangles AFE and DFC. We need to find the relationship. So we can say that triangle AFE is similar to triangle DFC, and that is because the reason is angle AFE equals angle DFC. They are vertically opposite, and then you have angle, so you have angle EAF, which is this angle, is equal to angle ADB. Angle EAF, angle AD, or angle FDC, sorry, EAF equals angle FDC. The reason is, of course, AE is equal to BD, is, it's a square, or AE is parallel to BD. ABD is a square. Okay, and using similar reasoning, we can say that angle AEF is equal to angle FCD. Very similar reasoning. So we've established this, and therefore the sides are proportional. Sides of triangle AFE and triangle FDFC are proportional. So what is the area of triangle AFE? So we have to draw a height. So if we have a height, so let height be h1 and the other height is h2. So area of triangle AFE is half times base, which is twice of x, times h1. h1 is the height, and so that is x h1, and area of triangle DFC or FDC equals half times x times h2, and that is x h2 divided by 2. Now, because the triangles are similar, the heights are proportional, therefore we can write h1 out of h2 is equal to, proportional to h1 is for 2x, so we say 2x out of x. So I can say the reason is heights are proportional. So therefore h1 out of h2 equals 2, and therefore h1 is twice of h2. So I can write the area, so that is, instead of h1 I can write 2h2, so I can write that is equal to 2x h2. I can write that, and the other area remains the same. So the other thing that we can do is, you see, h1 plus h2 is 2x, and we know that h1 is twice of h2, so 2h2 plus h2 is 2x, or 3h2 is 2x. h2 is 2 out of 3x. So we can use this fact in the area. So we can say now that area of triangle AFE equals 2x times h2 is 2/3 x, that is 4 out of 3x square, and area of triangle FDC equals half times x times h2, that is again 2 out of 3x, and that is 2 out of 6x square. Did I get right? Half h2 I have put in, yes, that's 3 times 2 is 6, so 2 out of 6x square, so that is 1/3 of x square, so I can write it as 1 out of 3x square. So we got the two areas in terms of the sides of the square, which is quite useful, because now we're going to work out the area of P and the area of Q. So now I'm going to say area of P, so I can write here area of P would be, so it's this triangle, so it is half times base, which is 2x times height, which is x, and minus the area of triangle DFC. So that would be the area of P. So we would write that half times x times 2x and minus the area of triangle DFC or FDC, which is 1 out of 3x square, and that equals the 2 gets cancelled out. So x square minus x square out of 3, and that is 3 minus 1, 2/3 x square, the area of P. And the area of Q is, so it's this entire triangle, that's half the area of the square, minus again the area of triangle DFC. So I'm going to write the area of Q is, and write half times twice of x times twice of x minus 1/3 x square, and the 2 and 2 go away, so I'm left with 2x square minus 1/3 x square, that is 6 minus 1, 5 out of 3x square. So therefore I'm going to write my final answer, ratio of area P to area Q, that would be area P divided by area Q. You see, I can write it as 2/3 x square divided by 5 out of 3x square, that is 2 out of 3x square times 3 out of 5x square, and if I cancel the x squares and the 3, that gives me 2 out of 5. So the answer is 2 is to 5. Again in a nice way. The answer is 2 is to 5.